So in this question we are given the graph of a continuous function g, which is the derivative of some other function f, which is the graph of g is shown here. And it is piecewise linear for interval negative 5 to 3, and it then is given by this formula, this quadratic equation for x between 3 and 6. And so what we are given f of 1 equals 3, and we need to find the value of f of negative 5. So let's use fundamental theorem of calculus, which says that f of 1 minus f of negative 5 is equal to integral from negative 5 to 1 of f prime of x dx. In this case, this is integral from negative 5 to 1 g of x dx. So let's add f negative 5 to both sides and then subtract this integral. We get f of negative 5 is equal to f of 1 minus integral from negative 5 to 1 g of x dx, which is, this is equal to 3 minus, and let's now calculate what this integral is. And so we can look at it at this chart here. It's area under the curve. So area here is a square 3 by 3, and it's below the x-axis. It means that this is negative 9. 3 times 3, negative 9. Then another area here is a triangle with a base 1 and height 3. So this is 1/2 times 1 times 3, negative 3/2. And again it's negative because it's below the x-axis, plus 0, and plus 1 because this is a triangle with base 1 and height 2, so it's plus 1, which is, this is negative 9.5, another negative, plus 9.5 plus 3, so it will be 12.5. So the answer is f of negative 5 is equal to 12.5, and this is our final answer. In this part of the question we are being asked to evaluate this integral. And so let's break it into two parts. Integral from 1 to 3 g of x dx plus integral from 3 to 6 g of x dx. And we can see that integral from 1 to 3 is actually equal to 4. This is this area here. It's a square 2 by 2, which is 4, plus integral from 3 to 6, and let's plug in the formula for the g of x, which is 2 x minus 4 squared dx, which is equal to 4, plus integrating this is just u substitution, x minus 4 equals u squared, and so this is equal to 2 over 3 x minus 4 to the third power, evaluated at the point 6 and 3. So let's plug in those values. 4 plus 2/3 times 6 minus 4, 2 cubed 8, minus 3 minus 4 minus negative 1, negative 1 to the third power, negative 1, so minus 1, which is equal to 4 plus 8 plus 1, 9, times 2/3 is 6, so 4 plus 6 equals 10. So the answer is 10, so this integral is equal to 10. In this question we are being asked on what open intervals the graph of f both increasing and concave up. And so the graph of f is increasing when f prime of x, which is g of x, is greater than 0. And then it is concave up when, again, f prime of x, which is g of x, is increasing. So let's look at these areas. So where is g of x greater than 0? It's on this interval from 0 to 6. And so on which of those intervals the function g of x is also increasing? And we can see it's between 0 and 1, it's increasing, and between 4 and 6. So the answer is 0 less than x less than 1 and 4 less than x less than 6 on those two intervals. So in this question we need to find all x coordinates of the points of inflection of the graph of f. And points of inflections are those points that the first derivative changes from decreasing to increasing or increasing to decreasing. And so we can go through this chart and see it's flat, then it's increasing, it's again flat, then it's increasing, then it's flat, then it's decreasing, and here it changes from decreasing to increasing. So the only point where there is inflection is x equal to 4. All these other points are not points of inflection because this is going from a constant line to a curved line, so it's not a point of inflection, and all of those are as well. So the only point of inflection is this one. Thank you, and I will see you in the next video.